Hello, this video serves as an introduction to Python. If you've taken Computer Science 111, then this is kind of a review. Or if you haven't taken any courses with Python, then this is your quick intro. It should be enough to get you going in Python. It's a pretty straightforward language. That's why a lot of people like it. Not a whole lot of ceremony. You know how in Java you have to set up this whole class file with public static void main and public class yada yada and compile it and all that sort of stuff. This is much more straightforward. You just start typing the commands that you want to execute in the order you want them to execute, and then you run the file. And even the syntax itself is simpler. We use tabs instead of squiggle braces, and variables don't need to say their type and things like that. So you'll see, but it should be quick to pick up. So what I mean by that is you could literally start a program that just says print hello, and then you can run that program. We're using Python 3. If you see anything about Python 2, just ignore it and move past it. Python 2 is way out of date. When you install Python, it'll often just be called Python on your computer, but this Mac has Python 2 and 3 installed for historic reasons. So I executed with Python 3. Even the print differs in Python 2 and 3. So if that print doesn't work, you know you're using the wrong version. So naturally, commands happen in the order you define them. So the x is defined to be 5, and then it prints x, and so on and so forth. So pretty typical stuff. You can import other code. This is like import in Java or include in C++. Import sys. You can also import as, so you can rename it if you have a long name for your import, but sys is fine. And then you can do things like sys.exit, or you can get the arguments on the command line. So if you have, after the word code.py on the right, if you put something else, you can say, these commands go in a list. So my 5555 is in the argv, the argument vector position 1. Position 0 is the name of the file itself, code.py. So that's not very useful to me. But the first thing that people type after code.py will be in this argv list. So that's what sys will provide. So there's a lot of other imports. We're obviously going to do import Flask for our making our web app. There's variables, as you see there. There's other kinds of variables. And or quotes like that, same thing. So those are strings, and there's a float. You can convert between them. You can convert y to a string, or that float to a string. You can convert a string into an integer or into a float if you just use the word float. So these are your conversions. There's if and else, obviously. So if x less than 10. Now, if, else functions and for loops and while loops, they don't use the braces. So this is where the indentation comes in. So you put a colon at the end there, and you tab one time, and then you put code that you want inside the if, and this code needs to line up with all the code in the if, unless you have another if inside, in which case it's further indented. So we could say else and if inside an else, if inside an if, and so forth. Of course, you don't need an else necessarily. And if you have an if or an else or a loop, and you don't know what the code should be in there yet, you can't just leave it blank. You know, you can't just put a tab and then put nothing else. So you have to use the word pass. That's kind of like a do nothing command, but I need to put something here because it's expecting something because I put a colon on the line before. So pass is how to just not do something. See, it's capital T true for true, false. Those are your booleans. Otherwise, it doesn't know what it is. And then we do have loops. Those are the same statement. There's no plus plus in Python. So you have your while true. So any loop that you can think of in Java or something you can represent here as well. For loops, we do it a little differently. For I in, so you use in and then so I will be all the different values inside this list. The list will follow. So you could do an actual list. And then I will be each of those values. Or you can make a range called the range function like that, and it'll be 1 to 9. So if you want to do it kind of like a typical for loop in Java, where it's like 0 to 10, this will be how you do that. It'll do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and it won't do the 10. It'll just quit at that point. Those are your loops. We can also define functions. So it's called def, and then give a name, and then your parentheses and a colon. And if you have variables or arguments to the function, you put them in parentheses. You can also have default arguments, which are arguments that are not necessarily provided by the user. So you can call this with myfunc with 1 value or myfunc with 2 values. Oops. And probably want to save the result because there's a return. All right, so those are functions. You can put a function anywhere you want in the list of code. Of course, it just needs to appear before you start to use it. Now, functions can actually refer to variables. So let's call this actually fx and fy. So this x here refers to the x defined above. So let's do another file where this is made more clear. So I'm going to define a variable count. And we'll say for I in range 0 to count, it'll be plus equals. So I made a list. I'm going to call the function. Show return. So it returns 21 because it adds 0, 1, 2, 3, and 4 positions. So this plus this plus this plus this plus this. So 4 plus 2 is 6, plus 6 is 12, plus 2 is 14, plus 7 is 21. So it only added this much of the list because I defined a function that said I'm receiving a variable, which I'll call my list. I'm going to start a counter at 0, and for I in the range 0 to count. So count's it's referring to that up there. So this is a global variable, and this is, s is a variable inside the function. My list is a variable inside the function. Count is global, so you can refer to global variables. And so it's only going through position 0 to 4, and it's adding them up and returning it. So when I pass in this list, it is returning the sum of the first 5 elements of that list. Now, if I try to do something like I have an error. So yes, it's referring to the global count, but you can't modify globals without using a special statement. So it says local variable count reference before assignment. So in other words, I'm trying to make count equal to something before I said what it is. By virtue of doing an equal sign, it converts it to a local, and now it's confused because it hasn't seen it before. So I'd have to say like count equals 0 or something to do this plus 1. But I don't want to do that. I want to change the original count. So I have to say global count. In other words, in this function, when I say count, I mean that one. Normally that's assumed unless you start trying to modify it and then it switches to local. But here I can modify it because I said it. I'm talking about the global one. So it adds one more thing, the next 7. And I've actually changed what count equals. So you can refer to global variables if you're not changing them. If you do want to change them inside your function, you have to say global. Obviously, be careful about that because now you're changing global variables, and that's typically a risky thing because it's hard to keep track of those changes. For data types, we have lists. Whatever. They're in brackets. You can add things to them with append. You can add 2 lists together. So that's how you concatenate 2 lists together, or you can add a single element at a time. And we have strings, obviously, and we have dictionaries. So we'll call it states, and then and so on. So here's a dictionary. Dictionaries are key values. Key is the abbreviation for the state, and value is the state name. Your keys and values can be pretty much any kind of thing, but they're separated by colon. And this is how it prints. It prints as defined, basically. And you can also print a particular value if you give the key, oops, in brackets. Oh, sorry, you didn't see that last one. Let me do this again. The way it prints is as it looks when I define it. I can also get to a particular value by giving the key. And there it's just that value. Or you can get all the keys. Perhaps you want to loop through them. It looks like this, but you can loop through them. You can also loop, oh, you can get the vowels as well. I think it's vowels, might be values. Yeah, I guess it's values. There are the values, Florida, California, Washington. Both lists and dictionaries you can use in ifs and loops. So you can say if, let's make x equal 3. If x in my list. So notice the word in, it checks if something is inside the list. That's pretty convenient. You can also say if S is in states. Right, so when you say if something is in something that's a dictionary, you're talking about is this key in the dictionary? And you can also loop through the list. So it's looping through all the elements of the list, and it's looping through the keys by default. You can loop through the values if you use .values and so forth. So those are lists and dictionaries, the main things that you're going to use. There's also a thing called a tuple. And they're used kind of like a list. You can get to a particular element and do something with it. So there's printing the 6 because it's 0, 1, 2, position 2. But the difference with tuples and lists is you can't change the elements of a tuple, whereas in a list you can change the elements. In a list you could say, you can rewrite the elements, but you can't do that in a tuple. And then lastly, I want to show you how to save and load data. It's called using pickle. And I guess the idea is like you're preserving the data for later. So you have to import pickle. And then we need to open a file and tell Pickle save the data into this file. So we'll say with open, it's called a PKL file. Write mode, because we're saving it. Bytes, because we don't want it to think it's simple text. Give the file a variable name that we'll use in the next statement. And then we say pickle, you dump the pickle, specifically, I'll dump this data, states, into the file F. And, it doesn't give you any message, but you'll see now, let me do that again. There is a file called my_data_pkl. If you try to open it, you can sort of see the data is there, but obviously it's binary, so there's stuff we can't really interpret. But it is the dictionary, the states dictionary, saved in a way that can be loaded. So we can come here and then load it. Read as bytes. You just load from the file and it's going to return, so you save the return value, and then you'll see that. States 2 is exactly what we had saved. So saving and loading, I did a dictionary in this case, the states dictionary, but you can do it with other things, lists, or you can make a dictionary with a bunch of keys, and each key is like a list or another dictionary, whatever you got to do. Lastly, there's a special type called none, or special value actually called none. It's kind of like null. So you see it says X is not okay. That's because none will turn out to be a false in an if. Or if you want to say, if you want to check if X actually is none, in other words, it's, like null, you would have to use the word is. Otherwise, you just use double equal signs as usual. Also note that in Python, instead of the vertical bars for ors and the ampersands for ands and the exclamation point, or you can still use an exclamation point, I think. I have to check, but use the word or and the word not. So you have to use the word or here. Right, so here that works fine. If you try to say this, it's going to have a problem. Yeah, it doesn't even understand that. So it has to be the word or. All right. Is there anything else that's important? Not for the moment. So as we get into actually using Flask, you'll see Flask sort of specific things, and you'll see some more Python along the way.